So 9.5, so far we have learned 3 things. We have learned inverse joint variation. We learned how to multiply and divide rational expressions. We have learned how to graph them. This section we're going to learn how to add and subtract rational expressions. So the main the main point of this lesson here is that you want to find a least common denominator. So something that's going to get all of the denominators to be the same. So we're going to start off just, with a few easy ones, because that's usually how lessons begin, right? So looking at number 1, both of these denominators are the same. So I can just combine the numerators. So when the denominators are the same, combine them. So 5w plus 1 minus w, and then would it be plus 5 or minus 5? Plus 5. Because that minus sign, I guess I kind of covered it up. That minus sign distributes to both. All over 2w. So from there you will simplify and then cancel anything that needs to be canceled. But do not kill any puppies, please.
So why is it w plus 5?
Because this minus sign distributes to the w and then to the 5. So then you end up getting 4w plus 6 over 2w. Is there anything else that I could do?
Divide 4 and 2.
I could pull out a 2. W plus 3 over 2w. Now can the 2's cancel? Yes. Only when it is multiplied can they cancel. So I couldn't do this. That would be killing puppies.
Oh, I definitely killed a puppy.
Cammy, you killed a puppy.
Wait, I think I might have did too, a couple.
Oh no.
I did kill one.
Oh, you will see a tally tomorrow of how many puppies have been killed.
Well, I didn't think
what
that
is
dividing was the same thing as cancel.
Okay, from there, now I can cancel the 2's without killing puppies, and I have 2w plus 3 over w. Can I do this? No, I can't.
Yeah, I definitely did that.
Yeah, I definitely killed a puppy.
Oh.
Claire, me and Claire killed puppies.
And that means you did.
Okay, try number 2 on your own. Denominators are the same. If I'm combining these, what goes on the denominator? 4. Some people like to say 8, but that is not true. That's not.
Killing a puppy.
That's not killing a puppy, but it's killing like a fish.
Killing a rat. A rat.
Can I do this?
Yes.
No.
No, Cammy.
That's on the video.
Good.
Okay, so then what do I do?
I want to go back
Then what happens? And it turns into 2a plus b. Leave it like this. Okay, number 3. Now the denominators are different. I need to find a least common denominator, something that they both could share. When you have 2 single terms, the easiest way for me to tell you how to do that is just them multiplied together. So AB would be the common denominator. So my next point from there, if AB is on the bottom, to make this have a B on the bottom, that means I need to multiply the top and the bottom by B. To make this be a B on the bottom, I need to multiply the top and the bottom by A. So sometimes when I have one like this, I think about cross multiplying.
So this is the answer.
B minus A over AB. And that's all you can do. Can't cancel anything else.
I I couldn't cancel them. Oh, never mind.
Because puppies die.
Puppy Friday. Already killed enough.
Why do I
Okay, so try number 4. Same kind of rule. So the denominator would need to be 5w. Think about cross multiplying. Because this needs to get multiplied by w over w. And then this needs to get multiplied by 5 over 5. So I kind of just think about cross multiplying them. You can. Can I do anything else?
No.
Nope. Are you sure? Okay. Just checking.
If it was a minus 25, would you do
Then you would factor. Yes, if it was minus 25. Okay, now we have something a little different for number 5. So we have 2 numbers, and then we have c and d squared. So if I combine them, what would my denominator be? 30cd squared. So then think about cross multiplying the top. It would be 12d squared plus 5c squared. This cross multiplying trick only applies when you have to multiply the denominators to get a common denominator. Which is typically when you have single terms on the bottom. Like you don't have x plus 3 on the bottom or something like that. Okay, what about number 6? Could it be, so if I multiplied them, it'd be 21a squared. Does it have to be a squared or could it just be a?
A squared be A.
Could it just be a? It could. Could I turn this into 21a? What would I need to do? Multiply it by what? Could I turn this into 21a? Multiply it by 7, right?
But can
So-
it still be 21A squared?
It could be, but then you'd have to multiply by 3a and then a, and then you'd have a lot of simplifying to do. And you'd have to do this by 7a and this by 3a. And then you'd have a lot of simplifying to do and factoring and such, and that takes a lot of work. So if they both had an x in common, then you wouldn't need to say x squared because they could both turn. Think about, can you turn both denominators into the final one? And how would you do so? So I'd multiply by 3 and by 7. So when I multiply this by 3, it becomes 6a minus 15b. Is this a minus right here? Yes. And then minus 7a plus 28b. And I put it in parentheses so that I can distribute the minus sign. Right, because I'm going to distribute here in a second. Yes, Roman.
Wait, wouldn't it be the opposite because you do 7 times 3 and then 3 times 7? Wouldn't it be multiply the 2a times 7a?
Well, it's already at, this is already at has a denominator of 7a. So to turn this entire fraction to have a denominator of 21a, I need to multiply the whole thing by 3. Because I'm trying to turn this denominator into this one. So that whole fraction gets multiplied by 3. Same thing for this 3a. I want to turn this denominator into 21a. So I multiply the whole thing by 7. So it's like you're trying to turn each individual fraction into the denominator. So then I'm going to distribute the negative. So it becomes minus 7a minus 28b. Then I combine my like terms. You get negative a minus 43b over 21a. Can I do anything from there? No. You guess you could pull out a -1 if you wanted. But there's really, I would accept either one. You don't have to pull out a -1. So these are examples when you have single terms on the bottom. What I mean is like 5a, 2b, and there's no plus or minus signs on the bottom. Once you get to plus or minus signs, finding the least common multiple is really crucial. And once you can determine that, I think it gets a little bit easier. So for number 7, if I have 24 and 16, what's the least common multiple for that? So what can they both turn into? That's the smallest number. 48. What about 15 and 8? 40. Yeah. Now, when you see something like number 9, the only thing, so when you have parentheses or factors, they are on their own. So x and x minus 1, the least common multiple would just simply be them combined.
Wait, 15 doesn't go to 40?
No,
15 times 2.
it's okay.
Yeah.
So what is it?
Yeah, that's right,
Yeah, that's
For,
right.
no, 45, is that right?
No. 45
No. No.
8 doesn't generate.
60?
8 times
No.
15.
30? 8 doesn't go into 30.
What's 8 times 6?
I'm wasting time on this problem. Somebody figure it out.
You're welcome. You're welcome. Are we on the video right now?
Yes, this is all on the video.
It would be 120. Is it 120?
I don't know.
You see, that's just something I don't want to figure out.
It's 120? Okay, that sounds right. If it's not, it's not.
Yeah, it's 120.
Okay,
420?
no.
You sure?
Whoa.
Whoa. Actually, I believe you said that first.
I believe Roman said it first. It's on the video as well.
Okay, so for number 9, when you have factors, so you'll see on the denominator, you will factor them. All of the factors combined become your least common multiple. So I'm going to write that out to the side. Factors combined become your least common multiple. And if they're repeated, you only write it once. So repeats, only write once. So let's say that both denominators had an x minus 3. You wouldn't say x minus 3 squared is your denominator. You would just say x minus 3 is your denominator. And we'll see some examples of that in a minute. Okay, number 10. So I have 3x squared, and then I have 12x squared minus 3. If I took a 3 out of this, 4x squared minus 1, then my least common multiple, these both have a 3 in common. Then I have x squared and 4x squared minus 1. So my 3's are repeated, so I only write it once. X squared is not repeated, so I write it, and then the 4x squared minus 1. So kind of the steps or the process that you go through is step 1, you simplify, and that's by factoring. Then you see what is repeated, and you only write it once. So list out factors, and then you would ignore or write repeats once, because repeats will most likely occur. for instance, on number 11, how could I factor this x squared minus 16? X plus 4, x minus 4. And this is x minus 4. So imagine you have two sets of fractions. One has a denominator of x plus 4, x minus 4, and one has a denominator of x plus 4. These are both repeated. So I'm going to combine my factors, but I'm only going to write the x plus 4 once. If I look at number 12, I can factor both of them. So how would I factor the left one?
X minus 4x. Wait, no.
Yeah, x minus 4, x plus 3. And then how would I factor the second one?
Plus 3.
Okay, and then I'm going to look at my repeats. X plus 3. They get repeated. So I want to list out all of my factors, but only write the repeats once. So x minus 4, x plus 3, x minus 3. Okay, let's look at 13. So, looking at both of these, what is my least common multiple? X plus 2, x plus 5. So, whenever I am combining the two, I need to multiply the left fraction by what? The opposite one, so x plus 5. So I've got 5 x plus 5 minus 8 x plus 2. From there, you're going to distribute because you kill puppies. So you get 5x plus 25 minus 8x minus 16. Then I combine like terms. So negative 3x plus 9. Take out a negative 3. And then put it over the denominator. Okay, let's look at number 18, because this is the last one that I want to do today, and then you'll do the first part of the homework. So 18, I'm looking at both of the denominators. What could I do to this one? It becomes what? If I factor. And then I have this a minus 3. It's repeated. So my denominator is just what? I only write the repeats once. A plus 2 and a minus 3. Now, on the left-hand side, so the left fraction, do I even need to multiply by anything to get the right denominator? Or is it already as is? So this fraction right here already has the right denominator. So I don't need to multiply it by anything, so I keep it as 3a.
Why not?
Because my denominator is already as is. I don't need to change anything to the left-hand fraction.
Does that mean you have to multiply 4a by both of them? Or 4 by both?
And then 4, how do I turn this denominator into this? What do I need to multiply it by? A plus 2. So 4a plus 2. So when you're doing these problems, imagine what do I need to multiply the denominator by to get to the final denominator? If it's nothing, then leave the numerator as is. If it's just one factor, then multiply by that factor. Then I combine, so 3a minus 4a minus 8. Negative a minus 8 over a plus 2, a minus 3. And you could pull out a negative 1 if you wanted.